notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. So far, these first 3 sections, all 51 videos, have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. Only 5 are published entirely on YouTube. Section 5, statistics. All 18 videos completed. 5 have been published in their entirety on YouTube, which brings us now to section 6, algebra. This is the first of 21 videos. Hopefully we'll have this completed by September 2025. Then section 7, functions, relations, and graphs, by October 2025. Section 8, geometry and trigonometry, by November 2025. And finally, section 9, vectors and matrices, by the end of this year. Disclaimer: this schedule is just a projection, which is not to be interpreted as a contract with anybody. As I just stated, section 1, number theory and computation. All 33 of these videos have been completed and published on YouTube, especially since these videos from section 1 form the foundation on which the rest of the syllabus is based. So please make sure you view these 33 videos and know them very well. Another reminder, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Section 2, consumer arithmetic. All 12 of these videos have been published in their entirety on YouTube. Section 3, sets. All 6 of these videos have been published in their entirety on YouTube. Section 4, measurement. These that you see here, highlighted in yellow, have been published in their entirety on YouTube. The others are only partially published on YouTube. Section 5, statistics, 18 videos. Again, these that you see here, indicated by yellow, have been published in their entirety on YouTube, and these others only partially published. We are now going on to section 6, algebra, and I have divided this section into 22 videos. There are 21 objectives, but one of these objectives will require 2 videos. So we have 22 videos in this section, as just stated. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions especially. CSEC recommends the following, shown at right, these here. From that, I would like you to pay close attention to these 2 here, since they form a very good 2-volume set of math textbook that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a complete course with CXC questions, by Raymond Tulsi. And this is a picture of volume 2. Disclaimer: I get no financial or other benefits from the sale of these books. Also, very recently, as of late 2024, I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, mainly questions from paper 2. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. Extremely important. This is the URL of that website. I will show you on the next slide what the home page of that website looks like, which is, this is the home page. You will have to register first, and subsequent to that, sign in. This is the URL again. I will include that URL in the description of this video, so you can just click on it and be redirected to this site. This is a reminder that you will be provided with a formula sheet for the CSEC math examination papers. And this is what the formula sheet looks like. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the syllabus, it is in the syllabus. This is the top part of that formula sheet. Note, you do not need to learn these formulae on this formula sheet, as I said before, this sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to know and memorize these formulae, you do need to know how to use them. Overview of section 6, algebra. We have 4 objectives here, which will be these 4 videos here. Then we have another 3 more, 7, which would be these 3 videos here, 5, 6, and 7. And then more overview, 8 to 11, these 4 videos here. Continuing, 12 to 16, these videos here. Notice objective 14 has been divided into 2 videos to be 14 and 15. Then finally, up to objective 21, that's these last 5 videos here, which would give us a total of 22 videos from this section. So we begin here, objective 1, which says use symbols to represent numbers, operations, variables, and relations. Firstly, algebra is not as difficult as some people make it out to be, or as you may have thought it is. Secondly, you began doing algebra in grade 2 or 3 way back in primary school, but it was not called algebra at that time. For example, you may recall maybe in grade 2 when you had a problem like this to do in your workbook. 6 plus, and there's a little box here, and the answer is equal to 10. You were supposed to fill in that number there. Or, still in grade 2, 3 multiplied by something is equal to 6. Or maybe in grade 3, something divided by 5 is equal to 3. And then in grade 4, 6, and now you are not given the operation. You have to say what operation. So what do you do with 6 and 7 to get 13? Now that's what you did in grade school. When you come to secondary school in grade 7, that same question over there now looks like this. 6 plus a, there's not a box here. 6 plus a is equal to 10. Now this looks like algebra. Or 3 multiplied by y, which is the same thing as you had over here in grade 2, is equal to 6. But sometimes you don't even see the multiplication sign. You see a dot here between the 3 and the y, and that means multiplication. Or you may see something like this. Instead of a box that you have to fill in over here in grade 3, divide by 5, you would see b divided by 5 is equal to 3. Or in grade 9, you may see something like this. 6 with that diamond shape there, and then 7 is equal to 13. What does that diamond shape represent? So now, as I said, this here is 4, and this here is 4. But this work that you were doing in grade 2 that does not look like algebra now looks like algebra because we are using symbols. And this other one here, 3 multiplied by 2 is equal to 6. Well, 3 multiplied by y is equal to 6. What is y? Y is 2. Or this one here, 15 divided by 5 is equal to 3. That's what you saw in primary school. Maybe in grade 8, you see something like b divided by 5 is equal to 3. What is b? B is 15. And this here, you have a 6 and a 7. What do you do with them to get 13? You add them. So now you have 6 with this symbol here, and 7 is equal to 13. What is this diamond symbol representing? And it represents plus. So as I said, you were doing algebra from primary school, but it was not called algebra, it was called arithmetic. But part of that arithmetic was actually algebra, as you could see on the right here. Now, let's consider 3 examples of what you may be required to do for this section, not specifically this objective, but just this section, section 6. Example 1. I think of a number. I multiply it by 3, then I subtract 2, and my answer is 10. What number did I think of? So let that number be represented by the letter A. So remember, we are looking at symbols to represent numbers, and then later on we'll talk about operations, variables, and relations. So if you let the number be A, we will represent the unknown number by a symbol. It could be A, B, C, D, whatever. Try not to use a letter that is similar to a number like B, because you may mix up the B with a 6. Or Z, you may mix that up, confuse that with a 2. So we are, in this case, using A to represent the unknown number. Now we will convert the word problem into an equation, and this seems to be the most difficult thing for students. Well, what did we do with A? If we let the number be represented by A, we multiply it first by 3, then we will subtract 2, and then we will say, well, that is equal to 10. So this is what we do. A multiplied by 3, put that in bracket because we are doing that first. We will then subtract 2, and that is equal to 10. That is the equation. Once we have the equation, we will solve it. And as I said, instead of a multiplication sign, you may see a dot there. So A multiplied by 3 minus 2 plus 2 is equal to 10 plus 2. I will explain how this is done later on as we go along. But for now, this is what happens. You do the same thing on both sides of the equal sign so that only the symbol remains on the left-hand side. So to begin with, we will add 2 on both sides. So we put a plus 2 here, and we put a plus 2 here. That way, we are able to get rid of that 2 on the left-hand side, the minus 2, and it becomes plus 2 on the right-hand side. So we get rid of it there, and now we will divide both sides by 3. So A multiplied by 3 divided by 3 is equal to 12 divided by 3. That 3 will cancel out that 3. 3 1s, 3 4s. So now you are left with A is equal to 4. So it would seem that the number I thought of was 4. In this case, we can easily check the answer to see if it is correct. So we take the 4 multiplied by 3, subtract 2, do we get back 10? And if we get back 10, 4 is correct. And yes, we get back there. So 4 is the correct answer. Now, if you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So example 2, remember right now, I just want to demonstrate that we can use symbols to represent numbers, maybe even operations and variables. So example 2, Charlie was sitting on a bench in the park when he noticed a group of fellow students walk by. He shouted out to them, "Hey, you 100 students, where are you off to?" One of the students replied, "We are not 100. It takes twice as many, plus half as many, plus quarter as many, plus you to make 100. How many students were walking by? Okay, this is not as difficult as it seems. First of all, we can guess. This is not a very good method, but we can guess it and get the answer. But it will take longer and it will not be systematic. But we can guess. So we'll, first of all, let's try 20. First try, we try 20. If you double 20, you get 40. You take half of 20, you get 10. Quarter of 20, you get 5. Plus Charlie here, 1. If you do that, you get 66. Well, remember, we want 100. 100. So 20 is too small. Let's try, second try, let's try 40. If we double 40, we get 80. Half of 40 is 20. Quarter of 40 is 10. Plus Charlie, 1. If we do that, we add them up, we get 111. So evidently, 40 is too large. So let's try a number between that. Let's try 30. If we double 30, we get 60. Half of 30 is 15. Quarter of 30 is 7.5 plus Charlie here. If we add all of those up, we get 83.5. That is too small, besides the fact you can't have half a student. So, fourth try, let's try 32, since 30 is too small. Double 32, 64, half of 32 is 16, plus quarter, plus 1, we get 89. Okay, so 32 is still too small. So evidently, our answer must be somewhere between 32 and 40. 40 is too large, 32 is too small. We can try 33, we could try 34, but it's easier here. In this case, we need a number that can be divided by 4 without a remainder. And the only number between 32 and 40 is 36. So let's try 36. 36, double 36, we get 72. Half of 36 is 18. Quarter of 36 is 9, plus Charlie, and yes, we now get 100. So using this guessing method, we can say that the number of students that was walking by was 36. As I said, this is not a good method, even though it works. Not a very good method. Let's try a better method in the next slide. In this case, again, we will let the unknown number be n. As I said, you could use any letter, but n seems to be very appropriate for number of students. So we will represent the unknown number of students by the symbol n. Well, what happened with that? We have to double it, twice as many, and then we have to add half of that number. Then we have to add quarter of it. Then we have to add 1, that's Charlie, to make 100. So we will convert that word problem into an equation. As I said, this seems to be the most difficult thing about algebra. Well, we take the n and multiply it by 2. That's 2n, that's twice as many, plus half n, which would be half as many, plus quarter n, which would be quarter as many, plus 1, that's Charlie, and that would be equal to 100. Once we have that equation, it's just a matter of solving the equation. So we could do that in 2 different ways. I'll show you here. 2 times n is 2n plus half n plus a quarter n plus 1 minus 1 is equal to 100 minus 1. So evidently, we are getting rid of the 1 on the left-hand side. If we subtract 1 from the left-hand side and we subtract 1 from the right-hand side, we will get rid of these 1s. So now what we have is this. 2n plus half n plus a quarter n is equal to 99. As we just did, we subtracted 1 from both sides. Now in this case, we will use an LCM. Remember that 2n over 1. This is half n, that's quarter n, that's 99 over 1. So what is our LCM? 1, 2, 4, and 1. The LCM is 4. So we put 4 down there. And now you say 1 into 4 is 4, 4 times 2n. And 2 into 4 is 2, 2 times n, and so on. And you get this. 8n plus 2n plus n is equal to 396. Now we can get rid of that 4 down there. And this is the equation we have. 8n plus 2n plus n is equal to 396. Well, 8n plus 2n plus 1n is 11n, and that is equal to 396. Divide both sides by 11. That will get rid of the 11 there. And that will give you n is equal to 36. So 36 students were walking past Charlie, as we discovered from the previous slide when we were guessing. Well, we could check that 36. We can easily check it. Twice 36 plus half of 36 plus quarter of 36 plus 1. Is that equal to 100? The answer is yes. And so we know that 36 is correct. And this time we did not have to guess. We use a systematic way of working it out. And this is really what algebra is about. Now, there is an alternate procedure from this point here. Instead of going through the LCM method, we could have just said half n plus quarter n, that's 3/4 n, plus this 2n, that would give you 2 3/4 n is equal to 99. And then you divide both sides by 2 3/4. That will get rid of the numbers on this side. And when you work this out, we get n is equal to 99 multiplied by 4 over 11, which gives us the same 36. So there is a systematic way of working in this question without guessing. And that is what algebra aims to do. Let's look at one more example before we go on. Harold is now 12 years older than Ashley. In 10 years, Harold will be twice as old as Ashley. How old will Harold be in 5 years? Okay, don't get worried. This is not as difficult as it looks. We follow the procedure. Let Ashley's current age be A for Ashley. So we will represent this unknown age by A. That's the first thing you will do. Then Harold's current age, since he is 12 years older than Ashley, is A plus 12. In 10 years, Ashley's age will be A plus 10, because she is currently A. And Harold's age will be whatever he is right now, A plus 12 plus 10. So far, so good. One more thing we need to do. In 10 years, Harold will be twice as old as Ashley. So what we will do, we will set up an equation so that Harold's age will show up as twice Ashley's age. So we will convert that word problem into an equation, and then we will solve the equation, and then we have one more step to do. So this will be Harold's age in 10 years. This will be Ashley's age in 10 years, but his age will be twice that of Ashley's. So we get 2 times A plus 10 is equal to A plus 12 plus 10. We have that equation and we will solve it. We will remove the bracket. So 2 times A would be 2A, 2 times 10 would give you 20. And that is equal to A plus 22. To solve, we will do the same things on both sides of the equal sign so that only the symbol remains on the left-hand side, only A. So what we will do, we will subtract 20 from this side to get rid of that plus 20, and we will subtract 20 from this side as well. And then we will subtract A from this side to get rid of that A on the right-hand side and subtract A from this side. So we get this, 2A minus A plus 20 minus 20 is equal to A minus A plus 22 minus 20. In this case, we are going to get rid of that. We are going to get rid of this. We can easily work 2A minus 1A is A, and 22 minus 20 is 2. So Ashley's current age is 2. Remember we said A represents Ashley's current age. So she is currently 2. So if she is currently 2, Harold is 14. In 10 years, she would be 12. Harold will be 24. Yes, that 24 is twice this 12. But that's not the question. The question says, how old will Harold be in 5 years? So we have to do one little thing more. In 5 years, Harold will be 14, because we found out that he is currently 14, plus 5, which would be 19 years old. Okay, please don't freak out on this. I know it may look difficult, but I told you it was not as difficult as it looks. And I will teach you step by step how to solve these problems and even more difficult problems on your own. All I wanted to demonstrate here is that we can use symbols to represent numbers. That was all. We can use symbols to represent numbers. As a matter of fact, we need to do that if we are going to do algebra. Now that we can use symbols to represent numbers, let us use symbols to represent variables. Let's go back to work you did in grade 3. Consider the rectangle at right. It has a length, L, of 6 meters and a width, W, of 3 meters. Calculate its area. So this is a rectangle here. You would have learned in primary school that area of a rectangle is equal to length times width or breadth. You may not have been told that that is algebra, but it is. You may have been told that it is arithmetic. So you say the area is equal to 6 times 3 because L is 6 and W is 3, and you get 18 square meters. As I said, in grade 3, nobody told you that that was algebra, but it was. In this case, the area is 18 square meters. Now, if we change the length and or the width, we may get another number for area. For example, let us just change the length. We keep the width the same as 4. If we change the length to 5, we will get an area of 20. Or 6, we will get an area of 24, and so on. Now notice that this area here changes depending on what the length and the width are. A, therefore, that represents area, is dependent, and it varies depending on what we input on the right of the equation. It does not always represent the same number. So A is called the dependent variable. It's a variable. It changes depending on what the other numbers are on the right-hand side of the equation. But L and W could also be any number in that equation or formula. They are therefore called independent variables. So we have independent variables are the one that you put in, and when you use those in an equation and you get some other answer, that is dependent. That is the dependent variable because it depends on the length and the width. A variation of that work, which we just did, may look like this. If A is equal to 2, B is equal to 3, and C is equal to 4, solve for Y. And you are told that Y is equal to A plus B plus C. That was work that you did in primary school. Or Y is equal to 3A plus 2B divided by C. Or Y is equal to A exponent B minus C. And when we work this out, we get 9 because we substitute. If A is 2, where A is, we put 2. And if B is 3, where B is, we put 3, and so on. And so we get 9. We get 9. Here, again, we substitute 3A. A is 2, so 3 times 2, and so on. C is 4, so we substitute 4 for C. We work that out, and we get Y is equal to 3. And then this one here, again, we substitute. A is 2, and B is 3. So 2 to the third power minus C, which is 4. And you work that out. That is 2 multiplied by 2 multiplied by 2, which would give you 8, minus 4, which would give you 4. Just to make sure you understand the difference between symbols used to represent numbers and variables. For the computer programmer, this is called a constant, where A is 2, B is 3, C is 4. But when you put that in these equations, Y are different numbers. In all three cases on this slide, Y represents different numbers. Hence, Y is a variable. Y is 9 there, Y is 3 here, and Y is 4 here. Now that we can use symbols to represent numbers and variables, let us use symbols to represent operations. We saw one simple example of this from an earlier slide, where I said that in grade 4 you may have done something like this. 6 with a box and a 7, and it is equal to 30. What do we do with 6 and 7 to get 30? In grade 9, instead of that box, you may see a symbol like this. Same thing. We found out that if you add 6 and 7, so 6 plus 7, you get 13. So this symbol here means plus. Now here are some familiar symbols that always represent a particular operation. Well, we already talked about plus. This one here is minus, you know that. If you see 6 with that slash, with that dash there and a 2, and you didn't know that that was 4, you would straight off say 6 minus 2 is 4. Or this, 12 with this sign here and a 4 here. If you didn't know that was 3, you would say, okay, 12 divided by 4 is 3. Or you could say it like this, 12 slash 4, that's 12 divided by 4 is equal to 3. And by the way, this division sign that you see here is colon, but continuing with division, you may see this, 12 over 4. This line here also means divided by. Or you may even see something like this. This is a long division sign, this sign here. You know that you are to divide 1,296 by 4. That is what the symbol means. It's an operation that you have to do. Then here, this one here, 4 multiplied by 6 is x. Or if you use Excel or you do computer programming, you may find that instead of that x, there is an asterisk. And even in math, for example, you have a 4 there and a 6 here, and it equals to 24. What do we have between here? Well, you could say that multiplication sign. You could say this multiplication sign, or you may see a dot like that. And this is used in mathematics. And that means multiplication. It could get more difficult than these, as the symbols to represent operations may not be familiar to you. For example, if you see 3 with this kind of upside down V, another 3, and it is equal to 27. Well, what is that? Well, it's called a carry, and it shows exponent. It means to the power of. So really, it is 3 to the third power, which means 3 multiplied by itself 3 times. So 3 times 3 times 3 is 27. Now, if you had seen just that without this 27, you would need to know that that is 3 to the power of 3, or 3 cubed. And most of the time, if you see that, you would know what it is. But if you see this one here, you may not know what it is. Sometimes, like you're on the internet and you're typing, and you cannot use this superscript here. So you have to use this carry. Now, finally, for this objective, let us use symbols to represent relations. We are familiar with most of these relations already. For example, 2a is equal to 3b plus c. You see that equal sign there? That's a relationship. Means equal to. You're familiar with that. Or you may see 2a with this sign here, and then you have 3b plus c. Now that sign means is greater than. So whatever answer you have on the left-hand side here is greater than whatever answer you would get on the right-hand side here. Is greater than. And then the opposite of that is less than. Now, if that sign up there means is equal to, this sign here means is not equal to. Not equal to. This one here, we can combine these two, 1 and 2, which is greater than or equal to. That's this sign. And of course, the other one, this way, is less than or equal to. Now, this sign here, you may not be familiar with that, but it means is approximately equal to. Whereas this sign here actually means is identically equal to. And then you have this one here, which looks like an equal sign with an arrow to it, with a greater than sign. What that means is implies 2a minus 5a divided by 3 implies negative a. You could have just used equal to, but this makes it look a little more sophisticated. Continuing, the use of symbols to represent relations, a slight variation on this equal sign. Y is equal to 2x plus 3. This equal sign here actually represents an equation. So for every value for x, you will get a specific value for y. And then you have this right arrow here that you will see in algebra or calculus, but we're not doing calculus. So it means mapping. It's basically the same thing as you have up here as down here. Now, and there are a few others that we will learn about as we continue with this and the next sections. So, objective 6.1 in section 6 on algebra, use symbols to represent numbers, operations, variables, and relations. So this brings us to the end of video 1 based on objective 1 in section 6.